Well, we have another question here. Question 8. The question says that the graph of g of x equal to ax squared plus bx, actually ax cubed plus bx plus cx, a cubic function having a y-intercept of 0 is drawn below. The x-coordinates of the turning points of g are -1 and 2. Now we have 8.1. The question 8.1 here says for which value or values of x will g increase. All right. Now we can see the function is increasing in this interval. Actually, the function increases only in between the turning points, or the decrease or increase. Okay, in this case, the function increases between the turning point from -1 to 2 there. So we can just answer it over here. We say from -1 lesser than x and lesser than 2. This is the way to say from -1 to 2. So now the following question is question 8.2. Another question here. The question says that excuse me. The question says that write down the x coordinates of the point of inflection of g. Well, another here, question 8.2. So we're looking for the point of inflection, the x coordinates, okay, of the point of inflection. Now, this will be another formula. I know the point of inflection is obtained by making the first derivative equal to 0. But another way, the second derivative equal to 0, but you don't know the value of a, b, and c over here. So this is what we can do. We can just work out the average between the turning points, okay? So another formula is by doing like x inflection will be like xtp1 plus xtp2 all over 2. Okay, so in this case, it will be x inflection, the point inflection, I can just write x will be like -1 plus 2 over 2, okay? And then this is equal to a half. Okay, and then the following question is question 8.3. The question says that for which values of x will g be concave down? All right, okay. We're going to consider the point of inflection, okay, to determine where the function concave down. If you look at here, actually a half, okay, the average between -1 and 2, we find is a half, which can be somewhere, let's say, a half can be somewhere here, approximately one is there, so a half will be approximately there. Okay, a half. So that's the point of inflection. Now, when the question says that for which values or values of x will g be concave down, note that concave down are those parts. Okay, you can see here it forms an inverse U shape. Okay, this is concave down. This concave up is those ones. Here it's concave up. You see? Concave up is here, like that. It goes like that. And that's concave down. Now, we need to find the values of x for which f of x concave down, meaning in the orange line, it's all the values of x that are more than a half. Okay, so 8.3 right here, 8.3. I can just write it over here. It will be like x greater than a half. Okay, Okay, if x is more than half, the function f of x concave down. Okay. Now the following question will be question 8.4. Question 8.4 here. Let's see it clearly. The question says that if g prime of x equal to negative 6x squared plus 6x plus 12, determine the equation of g. Okay, so it is given that g of x equal to ax cubed plus bx squared plus cx. Okay, and now they tells us it's also given that g prime of x equal to negative 6x squared plus 6x plus 12. Now, what can we do if we need to find the value of g? In other words, I'm looking for the values of the coefficients a, b, and c. How can I get them? Okay, for higher grades, they can use a method called integration. They can integrate the derivative to get the original function. But in grade 12 here, we cannot do that. What we can do, we can just differentiate g. Okay, g of x. G prime of x will be g of x. If I want to differentiate, it's going to be like when I use the formulas. Okay, for derivative, you know, when you differentiate a polynomial, you're going to differentiate each term of the polynomial. Okay, following this formula, a x to the power of n derivative, this will be equal to n times a times x to the power of n minus 1. Okay, for each term. So this will be 3. Okay, because over here a is still a, and then n is 3, so it's going to be 3 times a times x to the power of 3 minus 1 plus, okay, over here our a is b and n is 2, so it's going to be like 2 times b times x to the power of 2 minus 1, and then over here the exponent is 1, so we can write then plus like 1 times c times x to the power of 1 minus 1. Okay, and then this will be equal to 3ax squared, okay, plus 2bx, all right, and then plus c. Now we have another form of another g of x is given by this, so we can just equate the two. Okay, so it means that c negative 6x squared plus 6x, okay, plus 12 equal to 3ax squared plus 2bx plus c. We're going to look that, excuse me, negative 6 here will be equal to 3a. Okay, or maybe I shouldn't just write this. We can just do this. I was saying negative 6 here. Oh, I erased it accidentally. It was negative 6 there. And erase this. Okay. I was saying this negative 6 here is just equal to 3a. Okay, so this means I'm gonna write here 3a equal to negative 6. If I need to find a, I can just divide both sides by 3 there, and then we can get a equal to negative 2. Okay, now, and also positive 6 here will be equal to 2b. Okay, so we can just write 2b equal to 6. So I'm going to divide both sides by 2 to get b by 2, and then we get b equal to b will be equal to 3. And also, if 12 over here will be the same as a positive SSC. So we will do C equals to 12. Now that we have all the coefficients, we have like -2, 3, and 12, we can write our function g of x. So therefore we can say g of x will be equal to -2x cubed. That's a x cubed plus 3x squared, okay, plus 12. So that's g of x. Good. And then so that was question 8.4. Now the following question is question, well, it is this question 8.5. The question says determine the equation of the tangent to g that has the maximum gradient. Write your answer in the form y equal to mx plus c. All right, I prefer to move. Okay, let me read the question over again. It says that determine the equation of the tangent to g that has a maximum gradient. Write your answer in the form y equal to mx plus c. Yeah. I prefer to do it over here. I'll move my board over here. 8.5. We're looking for the equation of the tangent line, okay? Just right here, tangent. You know, tangent is a straight line and it's given by the form mx plus c. But now we want a tangent that will have a maximum m. So this m here must be the maximum gradient. So m max. Well, how can we do that? Okay, I prefer to start by drawing the diagram, okay, the graph of g of x, you know. Just want to show you something here. It is important to note that this function, we did find the point of inflection here, it was when, okay, let's say one is somewhere here, one is here between, okay, let's do it. One is between 0 and then a half must be somewhere there. If I try to be accurate, a half is here. Now, we did find that the point of inflection is the, now the point of inflection is actually where the gradient is the highest gradient, okay, the strongest gradient, that's the point of inflection, okay? You know, the gradient of a curve is not constant, okay? The gradient at this point is not the same as the gradient at that point, not as that and that, etc. But at the point of inflection, actually this place, as I was saying, okay, this is where it has the strongest gradients. So in other words, we're going to find the derivative at this specific point. Okay, so we know that's the gradients of a tangent line, or what we know that the gradient of the tangent line, or the gradient just is the derivative of the function. Okay, so we're going to find this gradient, the gradient at this specific point. Now m will be equal to the derivative was already given. M will be equal to g prime of x. It was given. We got it. It was -6x squared plus 6x plus 12 according to the previous question. Okay, so just gonna move here because of space. Okay, plus 12. Plus 12. Now, at the point that x is equal to a half, this is where we get the maximum gradient. So we're going to work out g prime of a half, okay? Which means wherever we see x, we're going to substitute by a half. gonna substitute by a half. So I'm gonna sub in a half here, a half there also. And then this would be equal to negative 6/4 plus 3 plus 12. And then this will be equal to, this is like negative 1.5 plus 15, which is equal to negative, actually positive 13.5. 13.5 is the same thing as 27/2. Am I right? Yes, because 13.5 times 2, yeah, 27/2. I prefer to use the fraction, maybe. So if I need to find now now we got the maximum gradient. So m max, okay, the maximum gradient is 27/2. Now, if I need to work out to find out the straight line, the tangent line, you know, is y equal to, as I said, as was given here, y equal to mx plus c. So when I say y equal to 27/2 x plus c. Okay, this c here, remember, is a straight line. C is the y-intercept. Okay, the y-intercept of the straight line. Now, to find the value of c, I need to find because the tangent line must pass. The tangent line is this line. The line, maybe I should just draw to show what the tangent line will look like. Is the line that touches this, the graph at that very specific point. Something like that. Yeah, something like that. Now I need to find just this an illustration. It mustn't be crossing 0 exactly, but you know, just because my graph is it's a bit thick. Anyway, I need to find now to find the tangent line. It passes through this point a half here. So I need to find the corresponding y value to sub there the value of y and x in order to find c. I know x is already a half. So now what is the value of y then? So when I sub y into the equation, the original equation here of the initial equation was g of x was 3x cubed. We did find it earlier. No, negative 2x cubed plus 3x squared plus how much was that? Let's check again. We find, yes, plus 12. So it was negative 2x cubed plus 3x squared plus 12 plus 12. So over here we're gonna sub a half. Okay, sub the value of a half here for x to find the y value. So this means y will be equal to, let's use a calculator. If I sub a half there, it's gonna be like negative 2 open brackets 1/2, okay, close brackets to the power of 3, and then plus 3 open brackets half, okay, to the power of 2 plus 12. This will be equal to 25/2, okay? So this will be 25/2. Now, I'm going to substitute this value in order to find c. So this means 25/2 for y equal to 27/2 times a half for x, okay, plus c. And then this will be equal to, okay, this will be, I think it's going to be easy if I just do 12.5 equal to, that makes 27/4, and 27/4 is how much? that's going to be 27/4. The product is like 6.75. 6.75. So basically did this product here, okay, plus C. Okay, let me first double check if I made any careless mistake here. Did I enter? So it's negative, it's here -2. Okay. -2 open bracket half to the power of 3, okay, and then plus because over here it's plus 3 half to the power of 2. 3 times half to the power of 2, okay, and then plus 12 times half, okay, and then we hit equal. Oops, I don't know what I wrote earlier. It's 13/2. So 13/2 is just 13/2 is 6.5. So here I would correct. So there it was, instead of 25/2, it's 13/2, which is 6.5. Okay. That was a calculator. I mean, my tablet, 13/2, which is 6.5. And then if I move it's going to be like 6.5 minus 6.75 equal to C. And then this will be equal to, so that means C equal to -0.25. Therefore, the tangent line will be equal to 27/2 x minus a quarter. Okay, that's 0.75, 0.15 minus a quarter. So this is the tangent line. Thank you.